Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
Hi, so this is Statics homework problem number 11.2. This has to do with a rigid bent bar, so it's a bent bar, and so there's two pivots. One is on rollers, and there's also a distributor force, and there are concentrated forces over here and over here, and the dimensions of where the forces are acting are given. So let's look at the problem. So there is 1350 pounds acting at point A, 1350 pounds acting at point D in opposing directions, and the distance, vertical distance between A and D are 12 feet. There's point C and point D, which are 9 feet apart, and so they are 9 feet apart from A and D as well, horizontally, and there is a distributed force of 760 pounds per feet acting uniformly from point B to C. So we're told to find the horizontal force on B, Bx, the magnitude and the direction of it, By, which is the vertical force at B, and the magnitude and direction of it, and we're told to find the Cy, which is the vertical force at C, and the magnitude and direction of it. There is no horizontal force at C because this is on rollers, so there cannot be any vertical force at C. Alright, so let's go on. Let's account for the vertical and horizontal forces on the bar. The horizontal forces on the bar, so there's a positive force here and a negative force here, and there's no other horizontal force acting on B and C points. So the positive force plus the negative force plus B of x added together should be equal to 0, and since the positive force is 1350 and the negative force is 1350, they cancel out, so B of x is going to be 0. So that's what we have here. Next, we take the moments about B. So we're going to take moments about this point over here. So if we take moments about this point, the first couple that we look at is the big one, which is the force being applied at A and D, which are in opposite direction. So it's a couple, and the distance between the forces is 12 feet. So and the couple is acting in the clockwise direction, so it's negative. So negative 1350 times 12 is the couple of strength. Next one is the force at Cy, which is 9 feet away from B. So we multiply by 9 times Cy, and Cy is acting in the positive direction in moments, so it's basically acting the counterclockwise, so it's positive. So we add that, and finally the distributed force of 760 pound per feet. The centroid of that force is at 4.5, so that's the distance, and since it's 760 feet is acting for 9 feet of distance, we have to get the total force. We multiply 760 by 9, and this is acting in the clockwise direction, so this torque is going to be negative. So negative 760 times 9 times 4.5. So we can get Cy from here because that's the only unknown. So we take the negative portions in this equation to the right hand side, and then divide by 9, and the Cy comes out to be 5220. Positive, and it's obviously going upwards. So that's basically Cy. This is third part of this problem, so we already found that. We know bx and we know cy. We need to find by. The vertical forces are there is by, cy, and then 760 pound per feet times 9. So those are the vertical forces. So 760 pound per feet times 9. This force is acting downwards, so this force is going to be negative. By and cy are positive because they're acting upwards. So by plus cy minus 760 times 9 equals to 0. So by is equals to minus cy plus 760 times 9, which is equals to 1620 pounds. So that's our answer to by. And once we got all three answers, once we put them in, 0 has no direction, so magnitude is 0. It's not up or down. It's not left or right. 1620 is positive, so it's upwards, and 5220 is positive, so it's upwards. And all these answers are correct. So thank you very much for watching. See you on the next problem.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.